Okay, so we're at 6.3. This is probably the most important lesson for the course, possibly. And if any of you guys are going to take statistics in university next year, this is mainly what they're going to be talking about: standard deviation, z-scores. They get into different scores as well. I think there's T-score, S-score, whatever. We're not going to touch on those. We're just going to touch on the z-score. So this is definitely something, if you're going to take math next year, this is something you're going to need to know thoroughly. And a lot of courses, business, if you're in sciences, businesses, psychology, well, often you got to take a stats course. So this is what it's going to be about. Okay, 6.3, standard deviation and z-scores. Okay, we're not going to use the variance formula. Maybe I shouldn't have put that up. But you notice the variance formula is very, very similar to the standard deviation formula. The only difference is for variance, we have a square on the outside. And if you square root it, you get your standard deviation. So if you cancel out the square by square rooting, you end up getting the standard deviation formulas. Okay, so we have two formulas, and one's based on population, one's based on a sample. You'll notice that the only difference between the formulas is the n here at the bottom. Ignore the symbols right now, but the only difference is this is n, which represents the population, and here's n minus 1, which represents sample. So you have to identify what the question is given to you. Is it giving you a population, or are they giving you a sample? Okay, and that will determine which formula you use. Okay, so what standard deviation is, it tells you the average distance of the score from the mean. So if you have a set of data, you find the mean, and then it's going to tell you how far away, on average, all the other scores are. Okay, so for instance, say our class average is 75, and our standard deviation is 3. That means, on average, each student is about 3% away from the 75. Okay, or I could say our class average is, I think it's like 78 right now. So 78, and the standard deviation is 5. That would mean the average student is 5% away from the 78%. Okay, so the average, 78, but on average, each person is about 5% higher or lower. Okay, so it could be higher or lower than the 78. Okay, the greater the standard deviation, the greater spread of results. Okay, so if you want to have a correlation, or you're measuring two things, the lower, smaller the standard deviation, the better the results are, the more two things are correlated together. Okay. If you have a standard deviation of 0, that means all the values are the same. Okay. Yes.
So the lower the standard deviation, the better.
The closer the results are, yeah. So if you're measuring something, or you're trying to do an experiment between two things, and you want to see if they're correlated together, the lower the number is, the more they're correlated together, so they're a better fit. Okay, or you have a massive standard deviation, and that means they're not related together. So for instance, say all you guys are 17 years old, your standard deviation would be 0. So we're all the same, okay, age. Some of you guys might be 16. I had birthdays recently. Okay, so now some of the symbols we'll go through. So this one looks like an O with kind of like a curl to it. So it has like an O with kind of a curl. This is, it has the same name as something else we learned, and it's sigma. So sigma, just like we had the symbol like this. This is like uppercase sigma, and this is like lowercase sigma. Okay, just like our alphabet, you have a uppercase letter and a lowercase. Okay, I know they don't look anything alike, but this is sigma, lowercase sigma, and then this is uppercase sigma over here. Okay, I want you, no, not there. So what we do in the formula is we take each x value and we subtract, what is this symbol called again? Mu, good. So it's not an m, it's not a u, it's a mu. Okay, so this is a mu, okay, which represents what? What does mu represent? It represents average. Okay, that's your average. You're finding the average of something, okay, or your mean. So mean is average. So mean, or your average. Okay, then n at the bottom represents population. Capital M is population. Okay, S over here represents sample, so nothing fancy with that one. And the N is your sample size. I do want you to add something over here on the sample. This should be X bar. Okay, there's no symbol on the computer to write it, so include an X bar on top here. And might as well do it over here as well. Under sample mean here, under Z scores, put the bar on top. And the X with the bar on top is called X bar. Yeah.
What is the X bar?
Sorry?
What is the X bar?
X bar is also average, or it's average or the mean of a sample. Okay, so they're the same thing. So mu is the average or mean, and so is X bar. But one is for a population, one is for a sample. So for these formulas here, don't really need to know variance. Just know to go from variance to standard deviation, you just square root. So they might give you a question in the textbook that variance is 10. Well, let's say variance is 9. What's the standard deviation? You just square root it. You'll get 3. Okay, so I'm going to explain or go through all the steps. So you see that big box that you've, if you had to print out, it's just kind of the steps in order to calculate standard deviation. It does take quite a bit of steps. Okay, and it is a little bit tedious in the work that we're going to do. But it's each x value minus the average. Once you do that, you have to square each one of them, then add them up together. Okay, so it takes a few steps. We'll do one in detail. Okay, then we have Z score. So was anyone still copying the other ones out? Okay, so a Z score tells you how many standard deviation of particular results or data is away from the mean. Okay, so it'll tell us how far it is away from the average. That should be a Z. These are Z's. Okay, so we have a population. It will be the x minus the average or mu divided by this symbol here, sigma, which is your standard deviation. Okay, and then for a sample, it's x minus x bar, which is your average again, divided by s, which is standard deviation. Okay, the exact same formulas, just different letters. So the Z-score tells you how many standard deviations you are away from the average. For instance, say our class average is 78 again, okay? And let's say Kate is 2 standard deviations above the average. Okay, remember the example I said, say our standard deviation was 5%. That means she would be 2 standard deviation away, which would be 10% higher. So her average would be 88. Okay, so the Z-score tells you how far away you are from the average based on standard deviations. And we'll do examples. You got there? I think everyone has that. Good. Again, it's going to be a little bit tedious. Okay, so what we're going to do first is list out our x values. Then we're going to take our x values and subtract our mean. Then we're going to take each one of those and we're going to square them. I feel left more space. Okay, so we're gonna take each x value, so I listed out all the x values. Okay, now we're gonna subtract each x value, subtract the mean. So take each one and subtract the average, okay? So mu represent average. Okay, you'll notice I'm using the symbols for population because in the question it says population. Okay, so how do we find the mean? How do I find the average, Sophia?
Add all of them together and divide by how many there are.
Good, so we're gonna add them all together, all these, and then divide by how many they are, which is 12. So 1.7 plus 1.4, 1.9. Plus 1.7 plus 1.5 plus 1.8 plus 2.0, 2.1. So I got 22. Someone double check it. Divided by 12. Okay, so we're adding them all together. Divide by 12, I get 1.83. I don't have my answers here. No, confirm that, 22?
Yeah.
Okay, so now what it tells us to do is each x value minus the average is 1.83. So we're going to take each one and subtract 1.83. So I'll write the first couple out. So 1.7 minus 1.83, which would give me negative 0.13. Then 1.4 minus 1.83 would be negative 0.43. And 1.9 minus 1.83 gives you 0.07. So we're taking each one and subtracting the average. Okay, so those are the values there. Get you guys caught up. So the first three I just show the actual calculation, and then I just finish off the rest. Okay, so just to break it down, and from the formula. So what we're doing is inside these brackets, right? So inside this bracket says take each x value and subtract the average. Okay, so each x value minus the average. Okay, so that's what we're doing in that first step. Then we have to square each one of those. So we're going to take each of these answers and now we square them. Okay, so that's the next step. So now we're taking this number all these numbers, and we're gonna square them. Okay, so what happens when you square it, they all become positive. Okay, you should not have any negative values in this row here. And I'm gonna keep a bunch of decimal places because so my answer is more accurate. So 0.0169. 1849. 0.0049. There will be definitely one question on the test that you have to do this. I'll tell you guys now. Some of them overlap, so as you calculate one, just put it in the other column. This. Just give you guys a minute to get that down. Okay, so we're going to the formula again, so x minus the average, so we did each one, then we square it. Okay, what's the next step now? Looking at the formula here. Sandra?
Would you add them all up and divide by the total?
Good, so now we're gonna add them up because that's what sigma tells us to do. Sigma means sum of. So each x value minus the average, x value minus the average, square it. Now the sigma tells us to add them all together. So what I got is 0.5663. Could someone just confirm that? It's very easy to make a mistake. Very easy. So if you have a question like this on the test, I would go through it 2 or 3 times. Double check your answers. Actually, let's push this over. Was that a sneeze?
Yeah.
Oh, bless you. double check for me? I think Kate's on it. And I don't have the answers right now, so I'm not 100% sure.
Are we just adding them up?
Yeah.
The total of all of the bottom ones is 1.251.
Holy moly. Let me double check now. Where did I go wrong? 0.0169, 0.1849, 0049, 0169, 0.1089, 0.0009, 0289, 24. Somebody else? I think it should be that. It should be over 1, I don't think. Cause that, if this is a 0.1 and that's a 0.1, it's not. I just double check. We'll just go with this one then. Logan, did you have it?
I'm close. You're getting 0.6113.
Oh boy.
Yeah,
well,
Alright, I
it's on-
got it.
It's just adding it, right?
Huh?
It's just adding it?
Yeah, those.
Yeah, I keep getting
So easy.
0.613.
See how easy it is to, sorry?
I think that is the answer.
This one, you got that?
Yeah.
Okay, so, we confirmed 1 then. It's so easy to make a mistake. So with 3 different people, 4 different people, 4 different answers. You gotta make sure you do enough of zeros. Oh, I see which one it's on. Which is 7, so I'll have 1 7, that's why. That one. It's 0.17, you had 0.77, that would be the difference. Yeah, so that's probably the difference.
Okay, which one are we adding now? At the bottom?
The bottom. Okay, one more confirmation, come on, Sylvia.
Zero point three one three.
Oh, boy, no. Okay, it's gonna go with this one.
Hold on.
Yeah, but you got it, right? Okay, you got the same as me. Alright, see how easy it is to make a mistake? Okay, so this number here,
No one else concerned that we all got different answers?
I double checked mine. I'll double check it again, okay? So this here, 5.5663, represents this whole numerator. Okay, so we have 0.5663 divided by, what's n represent again?
Total.
The total, how many, no, not total,
The
population size, right? Which is how many? There's 12 entries. So you divide by 12. So 0.5663 divided by 12. .047. And the last step, square root it. So I get 0.22 rounded. Just double checking on there's no negatives, right? When you get to here, so it should be all positive. Okay, so that's the formula for standard deviation. On a test, I will provide like something like this, and you can use the chart. Well, actually, I'll probably tell you to use the chart. Okay, so each x value minus the average. So make sure you find the average. I would keep at least 2 decimal places when doing the average. Okay, square each one, add them all up together, which is sigma. Divide by how many entries you have, and then square root. Okay, so what this means is the average is 1.83, and every entry is roughly 0.22, what are we doing? 0.22 units away from the average. Okay? I forgot to actually talk about this. You ever notice this? This is actually true. If you're watching a show and the commercial comes on, it goes louder. I don't know if you guys ever noticed that. Go home tonight, and maybe watching TV, if you do. When a commercial comes on, it actually gets louder. I don't know why. It's probably to catch your attention. So it happens all the time. When they switch to commercial, it goes louder. Okay. Okay, I want to keep that. Okay, now let's do some questions here. It's gonna keep on the side. So my average was 1.83, standard deviation was 0.22. Okay, so the first question says, are you still double checking that, Kate?
So that was,
I know, like 0.313. Okay,
I'll do it again after. We'll see if it's made any worse. Okay, B says, what would happen if the first measurement was 1.5? What was the first measurement originally? 1.7. So if this, instead of 1.7, it is now 1.5. What would happen to the standard deviation? Okay, so my question is this. The new number, is it closer to the average or further away from the average? It's further away. So if this measurement is further away, what is it going to do to the standard deviation? Sorry?
lower.
Not lower. It goes higher. Because the lower it is, the closer they are. So the lower the standard deviation, the closer, the closer the values are together. The higher standard deviation, the further apart the values are. So
1.5 was further from what?
further from the average than 1.7. Okay, so 1.5 is further from 1.8 than 1.7. So if it's further away, it's going to increase the standard deviation. So increase since 1.5 decibels is further away from the mean than 1.7. So standard deviation will increase since 1.5 decibels is further away from the mean than 1.7. going the other way, what would happen to my standard deviation? So SD is standard deviation just for short. If the second measurement was 1.7 instead of 1.4. So is the 1.7 closer or further than 1.4 from the average? It's closer. So what's going to happen to the standard deviation? It goes lower, it gets smaller. Okay? So it would decrease. The standard deviation will decrease. The standard deviation will decrease. Okay, because 1.7 is closer to the average than 1.4. This one's a trick question. See if anyone can get this one. What would happen if all the values were 1 decibels lower? What would happen to the standard deviation? So instead of being, so what it would be is, you don't have to write this out, so it'd be 0.7, 1.0, 0.4, 1.1, 0.9, 0.8, 0.7, 1.2, 0.5, 0.9, 0.8, and 1. Okay, you don't have to write that out. So question says, so if I decreased all of them by 1, what would happen to the standard deviation? Sophia?
They're all farther from the average.
Okay, well, the average, we would have to change the average. So the average would now be, I think, 0.83. I'm just making this up. I don't know if that's true. So if it's 0.83.
Oh, it would stay the same.
Yes. Standard deviation stays the same. Why?
Because everything was decreased by 1, not just one thing, including the average.
Yes.
So everything stays the same.
Yes. So standard deviation tells you how far spread they are, right? So for instance, in the original question, say that we had the highest value was, what was it, 2.2? The highest value is 2.2, and the lowest one was 0.4. Sorry, 1.4. So that's a difference of 0.8. Okay, so it's a difference of 0.8. Here, my highest is 1.2 and my lowest is 0.4. So that's a difference of 0.8 as well. So the spread of the results haven't changed. They're equally spread out. So if they're equally spread out, the standard deviation stays the same. Okay, that was kind of a trick question. Okay, it stays the same. Because the spread of the values are the same. This one takes a little bit of work. I might just do this lesson only, and I'll just post the next one for tomorrow. This is a lot of work. Okay, which values are more than 1 standard deviation away from the mean? Okay, so we have to see which values are further than 1 standard deviation. Okay, so here how it works. We have the lower end. Lower and higher. Miss Mackenzie. Hi. Hi. All right. So he's my second cohort. So he's in cohort Okay, so on the lower end, so if I was one standard deviation away, so it'd be 1.83 subtract our standard deviation of 0.22, which will give us 1.61. On the higher end, we're going to add one standard deviation, so we get 2.05. I'll explain this in a minute. Did you get that down? I'll explain. Okay, so one standard deviation from the average. So standard deviation from the mean or the average. Okay, so we go one standard deviation lower and one standard deviation higher. Okay, so I subtract to go to the lower end, which is 1.61. To go to the higher end, I add, so I get 2.05. Okay, so it says, is there any values that are further than one standard deviation? So what that means, are there any values lower than 1.61? And are there any values higher than 2.05? Do we have any? Yes? We do, right? Yes. And now we just list out which ones they are. I know we had a 1.4. Because 1.4 is lower than 1.6, so that means it's more.
1.5.
Sorry?
1.5.
1.5, good. And the higher end?
2.2.
Is there a 2.1 as well?
Oh, yeah.
2.1 and then 2.2. Okay, so these 1.4 and 1.5 are lower than the 1.61, and the 2.1 and 2.2 are higher than the 2.05. And what that usually means in the next chapter, which we're not going to get to, is when you're more than standard deviation away, you end up getting to the higher ends. Remember we did the normal distribution? So you end up getting to the higher ends. So for instance, in a class, if you're higher than one standard deviation away, you're probably on the higher end of the marks in the class, and this would be like the lower end of the marks in the class. Okay, now let's calculate the z-score of 1.7. And this is not difficult. So the z-value, so the z-score tells you to take your x value, which is 1.7, subtract the average, and divide by the standard deviation. So we have 1.7 subtract 1.83 divided by 0.22. Kate, I think you're right with your marks, with your, yeah, I think I calculated my standard deviation wrong. Was it 6.6068?
Yes.
Yeah. That's what I have on here, so I wrote something wrong. I just found my answer key. So for those watching at home, I did calculate it wrong. I'll watch it go. Okay, so now we just calculate this. So 1.7 which is negative 0.59. means is 1.7 is 0.59 standard deviations below, since it's a negative, it's below the mean. Okay, I know it doesn't really mean anything. 1.7 decibels is 0.59 standard deviations below the mean. So the negative means below. Below or lower. Good. And the last one. Last one. Calculate the Z-score of 2.2. So if you guys could do that. What was this one again? Negative 0.58? 9? Okay, so when you calculate for 2.2, you get a standard deviation of 1.68. Okay? So it says compare it to 1.7. So all I want you to say is this one is much further away from the average than the original one. Just looking at the number. Don't worry about positive or negative. So 1.68 standard deviations away means it's much further away from the average than 1.7. And then the homework's there. So 286, 1 to 6, 8 to 10. So what I'll do is I'll post a 4.4 video, sorry, a 6.4 video. I'll post it later on tonight. So just focus on this for now, for today, for you guys and for cohort B. So 1 to 6, 8 to 10.